Hola a todos, amigos de la comunidad de usuarios de Java Perú. Estamos aquí continuando con la jConf Perú 2024. En esta oportunidad vamos a estar presentando una charla con Simon Martinelli, referente a si realmente necesitamos Hibernate. Para tomar unos minutos y presentar a Simon. Simon es Java Champion, Balin Champion, Oracle Ace Pro, cerca de 3 décadas de experiencia como arquitecto de software, desarrollador, consultor y trainer. Como dueño de Martinelli LLC, se especializa en la optimización de desarrollo full stack con Java y tiene un profundo enfoque en las arquitecturas modernas y sistemas distribuidos. Constantemente comparte sus experiencias como ponente en conferencias internacionales, escribiendo artículos y manteniendo su blog martinelli.ch. Su pasión por enseñar se ve reflejada en su trabajo como profesor en la Universidad de Ciencias Aplicadas de Bern, en la Universidad de Ciencias Aplicadas Northwestern de Switzerland, donde enseña cursos de arquitectura moderna, sistemas distribuidos, tecnologías de persistencia y DevOps. Así que le damos el pase a Simon. So Simon, I will drop from the call and the stage is all yours.
Okay, thank you very much. The name of my talk is Do You Really Need Hibernate? And I was giving this talk at another conference a few months ago. And after the talk, someone came to me and said, hey, do you know Ian Beveridge's law? And I said, no, I don't know about that law. And then he said, Ian Beveridge was a journalist or is a journalist in England. And he wrote an article about titles. And he said, if the title of an article is a question, then the answer is always no. But we are in software development, and the answer is always, it depends. So I will introduce jOOQ today for you as an alternative to Hibernate, but it's not a replacement, it's just another way of doing persistent. And we will see how this works. But before we start with the database, we go to sports. I'm in a sports club since I'm a little boy. And in that sports club, we do track and field. We do long jump and running and stuff like that. And what we also do is we are organizing events for kids. So every year we have 2 or 3 events where they can come and have a nice day with other friends. And I'm usually doing the ranking list. And when I came out of school, I was looking on how they were doing it. And later on, after studying software engineering, I thought, they are doing everything by hand. So this should be easier. We should write some software. And the first version of this application was created in 1997. It was back in the days, it was Access, then later Java application, JavaScript, and now it's Vaadin with jOOQ, but it really doesn't matter. I use it as my pet project where I can try out new technologies, for example. And what exactly is this application doing? First of all, or the most important thing is it creates a ranking list. So here we have a ranking list. What we see here, it's in German because I'm from Switzerland and speak German usually. We have categories. For example, these are the boys, the oldest one from until 2005, for example. Then we have boys from 2006 to 2007. And we see here that we have the ranking list with the participant. For example, the Metzger Robin has like 80 meters. He had 11 seconds and 69. Or he had long jump, 3 meter and 46, and so on. And the number behind the result are the points. So my application is calculating points and finally creating the ranking list. The ranking list is the only part of the whole application where I need a nested structure because the ranking list is a tree. So we have the ranking list from, for example, Jugendmeisterschaft means JOUS competition. And then we have the categories. Below the categories, we have the athlete results. And that's it, right? everything else of this application is a classic CRUD application. So let me log in to the application, and then we see we have like organizations, and we, for example, have the athletes. Here I can filter the data, edit the data, and everything here is just flat. You know, I'm just more or less editing the database table. That's it. The only business logic that the application really has is if I enter the results, and for example, that's my son, I look for him, and then I change the result here. For example, he was faster, not 12, maybe 10, 15, and then it calculates the points. The points are calculated with a formula from the International Athletics Federation, but it's adjusted because we just have small to medium school kids or middle age, and then we just need to change that because the formulas are for adults. So that's it. So no more. Now the question that we have, if we think about persistence, is what approach do we have? And there are two approaches. And these two approaches are also the difference between the concepts of JPA and jOOQ. The first approach is called entity state transition. Entity state transition means I have entities, so Java classes, they have relationships, and based on some business logic, I change the state of the entity. And finally, I call something or a transaction is committed, and automatically framework like Hibernate is doing dirty checking, knows what has been changed in the entity state, and this is creating insert, update, or delete statements depending on what has been changed. The other approach is called dataset transformation, and dataset transformation is what I was showing you before. So if I update, for example, a participant, I just update the data. So that's CRUD, create, read, update, delete, or as it's called here, dataset transformation. The point is neither JPA nor jOOQ nor Hibernate nor any other solution is the best one. There is never a best solution. It's just the solution that is best suited for your requirements. So really depends on the application that you're building. One of these approaches could be the simpler one. In my opinion, it's the simpler one with jOOQ because I really have just this CRUD application and the ranking list that I want to build. Now let's start with jOOQ. jOOQ generates Java code from your database and lets you build type-safe SQL queries through its Fluent API. It's the point what jOOQ is doing. And there are some bits in this text that are very important. So if we have a look at the jOOQ, it is split into two parts. We will see that in a minute. But the very important thing here is type safe, and it's compiled time safe. And that's something very important because if you change the database structure or columns in the database, table names and stuff like that, your code will no longer compile. So you really have this check of your application based on the database. So that means jOOQ is usually the best choice if you have data-centric applications. And data-centric applications, in my definition, are applications that the purpose of the application is to change and display data. So we don't have a lot of business application. There's not a lot of business functionality or business logic, but you have a lot of data manipulation. And there probably this is a simpler approach. Now the question is where to start. For this talk, I have a example project. It's on GitHub. CMOSCH is my username, and jOOQ-examples is the project. You can check it out, have a look at it. It's a very simple project. It is based on the data model from my track and field application. There is also an official documentation, and for sure there is a demo application that also demos various database types. Now, because we focus on data-centric applications, jOOQ is database first. That means jOOQ assumes that your database already exists. So in Hibernate, for example, you can have both approaches. You can have first a database, then you can maybe, if you use IntelliJ, for example, there is JPA body integrated. You can generate your entity classes directly from the database, for example, or you can have the model first. So you just create your class model, and then you generate the database from your mappings, for example. But in that case, jOOQ always needs a database first, otherwise it won't work. But the good thing about that is jOOQ doesn't care about your database structure. So you don't have to follow any rules. You just can do whatever you want, and you can also access any database, no matter how old it is. Something that it's also important to say that with database-centric applications, usually the database lives longer than the application. And that's a very important fact, because that means that you have to treat your database very well in terms also of consistency, for example, because the database may be very old. For example, currently I'm working for a customer in Switzerland. He's creating an ERP product, and the ERP product is 40 years old already. So not the product that we are building currently, because that's brand new, but the database structure in the kernel of the database structure is still the same. So the database model evolved during the years, and currently we are working on the 5th version of the ERP system. So, but still on the same database. So that's something that's kind of special in terms of data-centric applications. Now, how does jOOQ work? jOOQ has two parts. jOOQ has a DSL, domain-specific language. I will show you Java code, but the jOOQ also works with Kotlin or with Scala. And on the other hand, we have a jOOQ generator, and the jOOQ generator generates these Java classes, the so-called meta model, from the database. And this is similar to if you have Hibernate with the criteria API and meta model API, where you also can generate such meta model based on the entity mapping in terms of Hibernate, but here we created on the database. Now the question is, where's the database? So do we really need a running database to run the jOOQ generator? There are, I would say, 3 approaches. The first approach could be I use Flyway or Lickybase, and I don't want to run a database to do the generation. So jOOQ should generate the meta model based on the SQL DDL scripts, for example. And this works to some extent, but not for everything, because for some things, the DDL statements must be executed to the database that jOOQ really can generate everything from the database that is internal of the database in the data dictionary. So using Flyway scripts or Lickybase scripts for the jOOQ generator is possible, but a bit limited. The other approach could be I have a reference database running somewhere and I generate the model from there. So I usually have to make sure that this reference database has the actual state, so the latest version. Every migration script has been executed on that database, and then I can use that database and generate it like that. Or the latest approach is the most modern approach, in my opinion. We have, since a few years, the test containers project. Test containers is a project that makes it possible to run any Docker image as a container for testing, and we can use that approach also to generate or to create a database and then to use that database for the jOOQ generator. And that's the scenario that I will show you during the demo. Then in one talk, someone was asking, does jOOQ scale? And that was quite an interesting question, because that's exactly why jOOQ was created. jOOQ was created by Lukas Eder initially. He's also from Switzerland, and he was working for a Swiss bank. and they had huge data models with a lot of stored procedures, and they were suffering from using Hibernate to access this database. And so they were looking for something else, and that's why Lucas created finally jOOQ, because it was way simpler to use against this huge data model. So jOOQ works for projects of any size. It doesn't matter how big it is or how small it is. In the ERP system I was talking about before is we have 2,000 tables in view and 5,000 stored procedures in the database, because the business logic is all contained in the database historically. And this will generate over 10,000 Java classes. Now, generated 10,000 Java classes is not really the problem. The problem is compiling 10,000 Java classes, because this takes a while. In our case, on our build server, probably it's not the fastest, but it takes around 5 minutes to generate and compile the code. So we cannot have that in the main project. We have a separate Jenkins job on the pipeline that will generate the meta model for us regularly when the database changes. Now let's go to the demo project and have a look at it. So this is a regular Spring Boot project. It's on the newest version. I use Java 21. It uses Flyway. In that case, it uses an in-memory H2 database just for the demo purposes. I will show you the same thing, but with Postgres in my pet project later on. And here we have a jOOQ CodeGen plugin that is used, and there we can say, for example, now in that example we use the DTL database, so we have Flyway scripts in DB migration. These are the tables, athlete, category, and so on, and we use that as an input, and then we say generate it to that package. And if we run that, jOOQ will generate classes. It will generate the class per table. So for example, we have the athlete table, and then it generates also constants. So the athlete is the table name. Then we have ID, first name, last name, and so on. These are the columns. And we also see that we have some additional data, like we know the data type, we know if it's nullable or not. We know, for example, that it has a default value from a sequence in that case. So these are all interesting information about the table. We also have like the primary key somewhere and so on. And on the other hand, we also get records. So for every table, jOOQ generates a record. And if this table has a primary or a unique key, the record extends from updatable record. And an updatable record is an implementation of an active record. So that means this class here has, first of all, the state. So we have getters and setters for all the fields, but we also have methods like store or methods like delete. So that means this active record can store itself. So we can use that, create such an athlete record, for example, and then call store, and it will do an insert or an update depending on if it's a new or an existing record. Now, let's have a look at some tests. I created a single test. It's just called query test. It uses this data model. Maybe to recap, the data model looks like this. We have like an organization. That means the application here is multi-tenant. It's a multi-tenant application. We can have multiple organizations want to do competitions. Then we can group competition into series. And finally, we have the athlete, which can have a club. And finally, he is in a category. He has results for an event. An event is like 80 meters run or long jump, high jump, and stuff like that. And that's more or less the data model. And based on the data model, we also have tests. But you can see here, it uses Spring Boot, and Spring Boot for testing knows test slicing. Maybe if you use JPA and Spring Boot, you already know data JPA test, for example, which only starts the pieces of the application context that is needed for this type of test. In that case, the jOOQ test annotation only starts the database connection and creates an instance of the DSL context that I inject here. The DSL context is kind of similar to the entity manager that you know from Hibernate if you're using Hibernate or JPA. And with the DSL context, I can create queries. So the simplest query that I can do is I can say, okay, select from competition, where competition is the name of the database table, that's the generated code. And then I call fetch, and fetch executes the query, and I get a result. The result is an implementation of a list because the result can be ordered, for example, and it is typed with competition record. So if I don't do a projection, I just use this shorthand, select from, then I get a record back. And if I run that, then we also can see that we can enable jOOQ logging, and jOOQ debug logging is quite useful because it displays the query that is executed. In that case, it doesn't have any parameters, but it has parameters. It will be displayed twice. That's a very important fact. If you're using jOOQ, jOOQ will always use prepared statements. So you will be safe from SQL injection. And then you don't have this problem. Then it logs some database information, and finally it samples the first 5 results of the result set. In that case, we just have one competition in our database. And that's very useful because you can directly see what happens. You can copy the SQL statement, execute it in a SQL tool or something like that, and this can be helpful during development. What we also can do is we can create insert statements. So we really do an insert into, and then we have the columns. We take the values. By the way, Mujinga Kambunchi is the fastest woman in Switzerland. He has Swiss records in most of the sprints events. And we can also use returning clauses, for example, because the ID in my database model is generated by a sequence. So I want to get back the ID, and then I can have a fetch into and return the ID directly and fetch it into a special type so I can tell what it will return. Now, this is more or less, I don't know, sometimes it's helpful, sometimes it's not, because, if you want to insert something, you usually do an insert in more or less all columns. And that's why we have also this updatable record. Means we can create a new record. I'm using that new record method because the athlete record is then connected to the database connection, or it knows about the database connection, and I finally can just call store, and store will execute the insert statement at the end. So these two statements, the insert into and this athlete record, does the same, but in my opinion, the second one is the better choice in that case because it's more, it feels more object-oriented and not on the database level. Now, storing and fetching data is quite simple if you just want to have these records back. But most of the time, if you're selecting data, you don't want to have all the data. So that's, in my opinion, very often a problem if you're using JPA and Hibernate. You directly fetch entities and use entities to display on the screen. For example, if we go back to my application, I have here a table, but in that table I display the athlete, but in fact I'm just displaying the ID, the last name and the first name, so I don't need all the other data of the athlete. So it doesn't really make sense in that case to select the whole record. So I can do projection. So for example, here I have select where I want to have the first, the last name, and the club name. And because the club name is on a different table, on the club table, I have to join the club and the athlete based on the club ID, which is the foreign key of the athlete. And what I get back is a record 3. So jOOQ has record 1 to record 22 for projections. And as you can see here, these records are typed. So here it's simple because these are just 3 strings. But if I have other types, then I would directly get those. So for example, if I use the ID, you can see it no longer compiles. Why doesn't it compile? Because this is probably not a string, but could be a long, right? So it's compile time safe based on the projection. Also, the result will be checked by the compiler. And then I get that back. I also can access the data here. So the record allows me to access the data inside the record in a also compile time safe way. So I can say athlete, which is the record 3, get me the column first name, get me the column last name, and get me the column from the club name. And then I get this data back as well. Now, this is fine, but not really handy, right? So you don't have a nice data structure. You get this record 3, whatever that is, no one knows. So it's much better to use a data class for that. And since we have Java records, which is an immutable data structure, which is a perfect fit, in my opinion, for projecting data, and that must be immutable, so we can directly use this athlete DTO. And here we see that we can create a query. It's the same as above, but this time we say fetch it please into the athlete DTO, and jOOQ will then use the constructor of the athlete DTO and return the data. And here it's just a fetch into, but we could also use a map to map data. It has various overloads. We have fetch, we have stream, we have various ways. Streams will create a cursor, for example. So we have various ways to get the data from the database. And finally, this does exactly the same as that from above, but with the difference that we have now a Java class that represents the record. Now, something that is a bit annoying is that line here. So we have to join. And if you're using Hibernate with the JPQL, you know that if you have a to-one relationship in your entity model, you can navigate from those. And jOOQ can the same. It's called implicit join. So instead of doing a join clause, I can do the join in the projection. Means I can say athlete, get me the club, and from club I need the name. And this will then generate, when the SQL statement is executed, it will generate a join. So the queries will be both the same, but here we don't have to write the join clause ourselves, because jOOQ already knows there is a club DTO, club ID, sorry, and this club ID is a foreign key. So if we look for foreign keys here, for example, we see that we have a foreign key. The minute we check it, we have foreign keys. There's the club. Here we have it. You have this club path, and this says, okay, we have a foreign key club, and this foreign key here is then also mapped, and here we see that the foreign key field or column is club ID. So that's how it works. And this is very handy. And finally, if we have the data, we may want to delete it. So we can do that and call delete from and execute it. That's all we can do. And that's just a very simple jOOQ application that you can use. But usually it's a bit more sophisticated or more complicated. We don't want to use H2, for example, because H2 is a problem, in my opinion. in terms of it's very good at emulating more or less every other database. It can be used for in-memory tests, but it's limited. So it's not capable to execute all SQL statements that are possible with the real database that we want to use. And for that, we have test containers. And if you don't know test containers, there is a website, it's called Test Containers. It was originally created by a company called Atomic Jar, and it was a few months ago, it was acquired by Docker, so it's now part of Docker. And how does Test Containers work? Test Containers is using Docker on your machine to create containers that can be run during development, for example, or during tests. If you're not allowed to install Docker on your machine, Test Containers also provide Test Containers Cloud, where your containers then run in the cloud and you don't have to install Docker locally. Now, this setup is very popular. And as I said, for generating the meta model here, the database, in the current application, it's using FlyWayDB, or in the jOOQ examples, and it uses H2. But we want to use the real database. And for that, you can have a look at my JTAF project. By the way, this project is available on jtaf.ch, and it's also open source and free, and you can have a look at it. And if you look at the POM file of this project, we see that there is not the jOOQ CodeChain plugin used, but the Test Containers jOOQ CodeChain main plugin. This one was created by Siva. He was a former employee of Test Containers, and he saw that this is a very common use case. So the very common use case is, I want to start a database in Test Containers. Then I want to apply either Flyway scripts or Lickybase scripts. Then I want to generate the jOOQ meta model. And that's exactly what this plugin is doing. So I can define my Test Containers driver. So it's Postgres. I use the JDBC driver. That's a simple tool that I created because I create some open source utilities around jOOQ. It doesn't matter what it is. But what we have here is we can configure the database. And here we have type Postgres, and I also can specify the image. So in my case, I use Postgres version 16.1. I can specify username, password, and database name. I don't need to do that, right? Because if I don't specify it, Test Containers knows that and populates it. Here I want to specify it for some reason. And finally, I define Flyway, or I could also use Lickybase. I define here the location of my migration script. That's just for demo purposes, because I don't need to do that because this is the default location. So if I use the defaults, I don't have to configure anything that just works. And finally, I have jOOQ generator. And with the jOOQ generator, I can, for example, define what's the input schema. In my example, it's public schema. I can also exclude tables. So Flyway is using this Flyway schema history table to track the versions of the history. Then I have a special Java generator that this generator equals and hash code based on the primary key. And finally, I can define where it is generated. And this exactly generates the same as we have seen before. So it generates the tables and the records. So that's exactly the same data model as we have in the jOOQ example class. Now, the interesting part of this application is that it creates this ranking list. And generating this ranking list is special because the ranking list is a tree. And as you may know, if you're using SQL, the result is always a table. So there is no standard way to create nested structures. Now let's have a look what jOOQ is doing. if we go to let me see, the competition ranking service, where we have it, domain, sorry, competition ranking service, we see the query, and I have to close all windows because the query is rather long. And this query here is, or this method get competition ranking is returning all the data that we need to create the ranking list. It has a parameter competition ID because I need to know for which competition I want to create the ranking list. And then it returns data. And this data are, again, Java records, and it has a nested structure. That means we have the competition ranking data. Let me check, or let me get back to the ranking list. Then we can see that. So here we have the ranking, the name, the competition date. We have some information about the medals that we have. And then we have a list of categories. So that's exactly the structure that we see here in the PDF that is generated. Then we have the category with the abbreviation name, year from to, and the list of athletes. We have a method to sort athletes by points, for example. We also want to exclude athletes, for example, that did not finish here in that case, but we don't want to lose them, so that's why we also include it. And then we have the athlete finally with first name, last name, and so on, and a list of results. And there we have, again, convenience method to calculate the total points that are displayed in the last column here of the report. And finally, we have the result with the event abbreviation, the result, and the points that we display just below the athlete name in that case. And this data can be fetched in a single query. So what we see here is that it starts normal with the competition name, competition date, the medal configuration, and then it starts with a multi-set. So the first nested structure are the categories. And here we say, okay, do a subselect with abbreviation name, year from to from category. And in the category, we have another multi-set, which is the athlete. Here we see that we use the relationship table. So we have an end-to-end relationship between category and athlete. And so we use that relationship table and then a implicit join for the first name, last name, year of birth, and the club name. And then we have the last multi-set where we select the results. And we have here some where clause with the join, for example. And we also have the possibility to order the multi-set results. So we can order that. And then we see converters. That means we must map the return value. So we see here that's a result of record 3. So because we have 1, 2, 3 attributes or columns. And then this is mapped to the reference of the constructor of our records. And this is happening on all levels. And finally, at the uppermost level. And here we also see another fetch method. It's called fetch optional, and this will return an optional ranking list data. And finally, this data will be used by a PDF generator that generates the data. And now we want to see that in action. So let's clear the console and create the ranking list. And let's see what's happening here. What did I do? Probably I didn't turn on the logging. Let me switch on the logging for that. So jOOQ has a logger, and you can set that to debug. And then we restart that. Now we see that we get the queries. So usually logging does the query as it is. jOOQ always uses prepared statement. So we see here the placeholder for the parameter, but jOOQ, for convenience during debugging, does also inlining the variables or the parameters, and then prints out the inline SQL statement that we can use that, for example, to execute it somewhere or just to see what happens. So that's very convenient to do that. But because it always uses prepared statements, you will not get SQL injection. And what jOOQ also is doing, it samples the data. Usually it samples the 5 first results just to get an idea how the data looks like that you get back. So it's very convenient to check if your SQL queries are correct or not. So that's it. And now let's go back to the ranking list, and because we want to see how the ranking list query looks like. And the query that is generated here starts more or less normal. So we have the columns from the athlete, but then it starts with the multiset. And the multiset here it looks like JSON because it uses JSON functionality. So let's copy the query and open it in SQL editor. So I can format it. And this is what jOOQ has generated from my query. So we see that we have here JSONB aggregate it uses a Postgres database. That's why it has JSON aggregate. It has JSON build array that is used to structure the nested data. And if we execute that, I should be able to execute that as well. No, I can't because I don't know where my database is running, but it really uses this JSON functionality to get the data back, and then it will transform it into our objects. So that's how jOOQ works in a brief introduction. There was a question, which JDK 21, which Hibernate version should I use? You should always use the latest Hibernate version. So currently it's 6.6 something, I think. But if you Spring Boot or using Quarkus, you always get the latest hibernated version with that usually. Now, if you have jOOQ and JPA or jOOQ or JPA, which one should you use? In my opinion, the superpower of jOOQ is really querying. So the nested structure with multiset is very handy if you need nested objects like I do for my ranking list. If you have functions, store procedures, user-defined types, stuff like that, then go with jOOQ. It's way easier. You get classes for all this type of database objects. And if you need to do bulk updates and deletes, very often it doesn't make sense to use JPA for batching or batch processing, for example. You don't want to read entities, then change entities and store them back in the database when you already have all the necessary information to just execute an update or a delete statement. That's way easier if you're using jOOQ. But also JPA Hibernate has superpowers. So for example, this entity state transition, you have this cascading on to many relationships, for example, with orphan removal, where you can just take an entity out of a collection and then Hibernate will know that it has to delete this entity. That's very comfortable as well to use. That's it from my side already. Do you have any questions?
Simon, thank you very much. I have another question. What book or resources do you recommend to learn jOOQ?
Yeah, I can show you. So first of all, jOOQ.org is the place to go because you have a great documentation. You have also documentation for older versions or versions that currently are under development. Something important when we are on the web page is jOOQ is not free in all cases. So if you're using like an open source database, for example, one of those like H2, MariaDB, MySQL, Postgres, then it's free, completely free. But if you're using like Oracle or SQL servers, so all databases that are not free, then you also have to pay for jOOQ. So it's not that expensive, but the point is jOOQ is implementing special code for each database type, so it's database agnostic, and that's the way how jOOQ earns money, and that's why it's so successful and still on the market. And if you want to go deeper inside, there is a book from Angel Leonard about jOOQ. It's also here. Wait a minute. It's this one, jOOQ Masterclass. And I would really recommend that book, but it's not for the beginner. So you should maybe first go into my examples or read the documentation and get an idea how jOOQ works. And then you can go into that book and learn everything that jOOQ is doing. Now, the second question is, how was your experience combining jOOQ and Hibernate? This quite works well. So it doesn't really matter because they do not interfere somehow, because you could go ahead and just use jOOQ for all reading data. You can also use jOOQ to craft the SQL statement, and then you can use JPA to execute the native query, for example, because if we look at the code, for example, here, in that case, I just fetch the statement. But what I also can do is I can say get query. And with that query, I also can finally inline it and then directly execute the query with JPA. So I don't really need to use jOOQ to execute the statement, but I can use jOOQ to craft the statement. And if I use then Hibernate to execute the statement, I'm also able to get back entities from the query. So I can really combine both. But once you are used with jOOQ, I don't really know if you still want to go back to Hibernate, by the way.
Thank you, Simon. I have another question. How was your experience combining jOOQ and Hibernate?
Yeah, that's what I was talking about already. So you really can combine that. By the way, I have an example. That must be here somewhere. jOOQ. Let me see that. I think that's this one. I'll go to this other branch. Here we see what I was talking about. So we can create a jOOQ query. So that a bit bigger. I can create the jOOQ query, so like that. And then I can call get SQL. And this returns a SQL string. And this SQL string I can use here, say, let's create native query. And from that SQL query, I get back entities in that case. So I can combine that. Yeah.
Okay. Okay, Simon. We are truly grateful for your invaluable contribution for our conference. Your two talks have not only enriched our knowledge, but also inspired us greatly. Thank you for sharing your time, expertise, and passion with us. It has made a lasting impact. Thank you, Simon. If we
Yeah.
meet a conference or Java 1 2025, I'll bring you a special gift from our community.
Oh, cool.
Buying coffee
Thank
from
you.
Peru.
Thank you very much. I'm looking forward for that. Yeah, it was a pleasure to be here. Thank you very much for having me.
Thank you very much, Simon. Have a great day.
Yeah.
Thank you, guys. Thank you, chicos. Gracias por participar en las dos talks de Simon. Por favor, darle las gracias, enviarles muchas vibras a Simon. Simon, thank you very much. See you. Take care.
Bye-bye.
Bye-bye.